Good greetings to all. This is an introduction video about the serial communication programming and its interfacing with the 8051 microcontroller unit. Initially, 8051 is an 8-bit microcontroller unit from the Atmel family. So, in the communication protocol, most widely good greetings to all. This is an simple video on serial communication and its interfacing with the Atmel 8051 microcontroller unit. As we know, the communication in the microcontroller unit is based on either the serial transfer or the parallel transfer of data. Let's see a simple representation on serial transfer. In the serial transfer, we have an peer-to-peer communication line, a one line between the sender and the receiver. On the other hand, if it is a parallel data transfer, we have an sender with data lines of either maybe 8-bit or 16-bit from D0 to D7 across the receiver. So this is the major difference between the serial data transfer and the parallel data transfer. Let's have a communication protocol between the transmitter and receiver. As per the strategy, we have three parts of communication. It may be a simplex communication and then half duplex communication. Finally, we have a full duplex communication. In simple words, in the simplex communication, there will be a data transfer line from the transmitter and it ends towards the receiver. At this instant, the only data can be transferred from the transmitter to the receiver at the instant. Likewise, in the half duplex communication, we have a common data line between the transmitter and the receiver. Here, each and every block has the transmitter and the receiver on its own. So on the one end, the transmitter shares the data to the receiver. At this instant, receiver in the transceiver side, it cannot transmit. In a simple way, at one instant, it can act as a transmitter or a receiver. It cannot perform both the operations of transmission and reception simultaneously. That will be the advantage of using the full duplex communication. In this scenario, the transceiver has two data lines. It can transmit simultaneously. It can able to receive the data. So this is the special about the full duplex communication protocols. Let's see the importance of the baud rate with the Atmel 8051 microcontroller. In this case, let's see a small example. Here the XTAL refers the crystal oscillator frequency. It has the crystal, it will create a frequency of 11.0592 megahertz of oscillations for the 8051 microcontroller. As we know, the registers TH1, it has the baud rates of 9600 and then 2400 and 1200. This is called as a timer 1 registers, which has a different baud rates. So for the serial communication, the timer register is most important. It is the one it will generates the baud rate. In this scenario, you can ask me the question on what is called as an baud rate. It is the data transmission rate or bits per second of data transfer from the microcontroller to the output serial unit. How we can create the serial port communication is based on the simple block diagram. Let us see the simple box representing the oscillator frequency having 11.0592. In order to get the serial port communication, the baud rate has to be maintained by dividing this XL frequency by 12 parts. By this we can get the single machine cycle frequency as 912.6 kilohertz. Again, it is subdivided into 32 parts by using the UART protocol, that's called as a 28,800 hertz. This is the frequency that is given to the timer 1 to set the baud rate. On the table 4, we are representing the timer register values in terms of decimal and in terms of hexadecimal code for the different baud rate starting from 1200 to 9600.